using modules, payloads, and exploits to own a computer. We're going to do this with two different interfaces. We're going to use the MSF console and we're going to use Armitage. They both, behind the scenes, are using the same techniques to implement the attacks, and we'll see both of them in this video. And as a quick reminder, only use these tools on networks and devices where you're explicitly authorized to do so. Having said that, let's begin. I am very happy that you joined me for this video. Our objectives are simple. We're going to own this computer right here at 10.0.0.2. Now, that's the end picture. But in the process of getting there, our other objective in this video is to also walk you through the concept of using various modules with MSF console, various payloads, the actual code that we want them to execute, and various exploits, taking advantage of weaknesses that may either be injected or come from the factory in the operating systems that are running on our networks today. One of our challenges that we're going to have is that if we're working on multiple different networks and different customers, and let's say we're at this site on Monday, and we scan the network and we find these two devices, we can keep those inside of a database inside of Metasploit, which is really cool, the Metasploit framework. However, if on Tuesday we're at a different customer scanning their network, we don't want to keep those in the same exact database. So we have workspaces. You can think of them as logical sections of the Metasploit database where we can organize the discovered hosts. So when we go to a new site, what are we going to do? We're going to discover what devices are out there using a scan tool, either the Metasploit built-in scan tool, or we can use Nmap. They both work great. And then we can go ahead and decide, based on what we find, which modules we want to plug in using the command called use for that module. And then we can specify the actual payload that we want to use in conjunction with that module. And then we can specify the parameters involved with the IP addresses of the devices that are going to be involved in the attack. And then to launch the exploit, we simply type the word exploit. And then, based on the module we've loaded and the payload we've selected and the host we've identified, it'll go ahead and launch that specific exploit. So let's start off by going to the MSF console by simply launching the command MSF console, and it'll take just a few moments to load. And we now have the MSF console to work from. Now, by default, when we work with MSF console, there is a database that we're working with, and it's called the quote-unquote default database. If we want to see the details of that, we simply type in workspace, press enter, and it says you're in the default workspace. We can also see some details regarding the database in general, and we can do that with the command of db_status. Now let's imagine that we wanted to create a brand new workspace, a logical section, if you will, of the database for a current customer. How would we do it? Well, just like with most everything else in the world of Linux, there is help just a few keystrokes away. It's going to give us the options for how would we create a new workspace, or how would we delete one for that matter. So as an example, let's create a brand new workspace called Test Lab 1. So it's workspace-A, the name of the new workspace we want, and poof, not only have we created the new workspace, it automatically has put us in there by default. This little asterisk right here represents the workspace that we're currently working with. I'm a big believer in verifying what we think has happened, so let's just issue the workspace command one more time, and it should show us the default workspace and the workspace that we're currently associated with. This looks perfect. Now let's say the next step that we want to take is to scan the network. Now we could just use Nmap, and Nmap will actually work from here, but if we want to use Nmap and to put the discovered results into this database inside of our workspace, we're going to use the command db_Nmap, and then we'll give it a fairly aggressive timer. We'll use the -A to say, hey, let's go ahead and throw the kitchen sink at this thing, and we're going to scan just one IP address. Now this would also work against the entire subnet. We say 10.0.0.0/24, and that would sweep the entire range, doing all the wonderful things that we learned in a previous nugget that the -A has to offer. And it is done. Now, if that didn't feel quite like the full 30 seconds, which it claims it took, that's because I snipped out about 25 of those seconds. I didn't want you staring at a screen waiting for this Nmap to complete. But now that that's done, check this out. It's now inside of the database in our workspace called Test Lab 1. Now, to see that information, we're going to use the command called hosts inside of the Metasploit framework console. And if we aren't sure what the options are for host, we can use host-h for help, and then we can issue the command host all by itself, which is going to show us that, okay, great, at 10.0.0.2, this guy's MAC address is that. It's a Microsoft Windows XP box. Looks like it may not be running any service pack. Regarding the actual hosts inside our database, based on the scan or scans that we've done, we can also say, please show us the services. Now, the services command, just like the others, there's a -H that can say, okay, here's how you can specify additional options for the services command. But if we just want to see services, just type in services, press enter, and it's going to give us the services, the open ports that it discovered for any of the hosts inside of the workspace. All right, now for the fun part. We've identified a host. We know it has some open ports, and now we can go ahead and launch or load a module into the Metasploit. One of the things we could do is search for something specific. For example, in general, if we needed help with the search command, we could do search-H, and that specifies some of the options that we can use to go ahead and search on. So let's imagine that we've heard about this brand new vulnerability and somehow it leverages NetAPI. And we wanted to search for modules which included anything related to NetAPI. We can just type in search space NetAPI, and it would show us a list of modules which include that. So I've got the font fairly big, so it wrapped a little bit, but here it has the actual name. So these are all exploits, and they all have NetAPI somewhere in them. And what I'd like to do is let's go ahead and use this guy right here, the exploit Windows SMB MS08_067 NetAPI. And it has a ranking of great, which, now, great, let's use it. It doesn't mean great, let's use it. It means if it has a very high chance of success or very easy to implement. So that's what the ranking is all about. So let's go ahead and use this specific exploit. So how do we tell the MSF console that we want to load this module and use it? And the answer is, it's the same as in the previous nugget when we did the SYN-FLOOD. We're going to go ahead and specify the keyword of use, and then we're going to simply put in exploit Windows SMB and the name of that module. And you'll notice the prompt changed. So the prompt is now reflecting that we are logically sitting in that module or in that space, if you will, ready for the next set of commands. Now, with this exploit, there's a various amount of payloads that we could deliver to the victim using this exploit. And to do that, we're going to go ahead and do a show payloads, and it's going to list all of the payloads that we could potentially use with this module. Out of this large list of payloads that work with this module, we would then choose the one that we want to use. So I have a personal favorite here that we're going to try out. If we scroll up or down, if I can find this, Windows Shell Reverse TCP. And we'll scroll down a little bit farther. There it is right there. That's the winner right there that I want to use. When this payload is executed, it allows the remote device to open up a listening port, and I can connect directly to it, effectively making a covert channel between me, the backtrack system, and the device that we're attacking. Our next step is simple. Once we've decided on the payload that we want to use, we simply tell the MSF console under the module that we're currently in that we want to use that payload, just like that. Our next task is to identify and set some of the variables that are inside of this exploit. So to take a look at what those are, we can do a show options, and it's going to show us all the options that might need to be set. So we're definitely going to want to set the remote host, that's our victim, and his address is 10.0.0.2 on the network. And we could go back to our scan to see that is his address and that he was there, but he is. And our local address, the local host, which is the attacker machine, is 10.0.0.4. And I'll verify both of those before we launch this attack. But we need to set the R host and the local host both to the correct IP addresses. So we'll set both of them. So we'll set our host to 10.0.0.2 and we'll set the local host to 10.0.0.4. And let's just take a moment and verify that we really do have the right addresses involved. So let's bring over the XP box. This is the actual screen of that device before the attack. And we'll just go to command prompt and do an IP config and just verify his IP address 10.0.0.2. That is great. And I also happen to know that the backtrack system that we're sitting on, where we're running MSF console, does have the address of 10.0.0.4. So those parameters look good. Just to verify that all the details are in place, we're going to do a show options just to make sure that what we think we set, we did. This guy is going to become a server. We're going to connect to him. which effectively, once we have that covert channel between us and the victim in place, we can do virtually anything we want with that device. So to now launch the exploit, it couldn't be easier. We're going to type in exploit, the word, it's going to execute, and it's going to automatically generate a shell, an interface, a command line interface between us, the Backtrack attacker, and the actual victim, which is the Windows XP box. So this is interesting. It started the attack by going to port 445, which was the SMB service port, and then it spawned off a new listening port of 1047. So from our Backtrack machine, this is us. We're connected on source port 444 over to 10002 to port 10047. And this, my friend, is the literal command line interface of our victim. Now we can execute any commands we want to right here. For example, in a Windows box, if we want to clear the screen, we type in CLS, press enter. It does the same thing here. If we want to move around in the file system and don't want to be stuck in this system32 folder, we can just use the CD command. If we want to take a look and see the file system there, we can do a dir. That'll show us all the current files in that current folder that we're in. If we want to make a brand new folder, we can use the make directory command, mkdir, and then the name of the new folder that we'd like to create. We could go ahead and change and go into that directory if we wanted to with a CD space and the name of that folder, just like as if we are sitting on that local victim's machine. Another Windows command that we could issue would be like route space print to verify what the routing table looks like on this device. And we could also use netstan. I like to add the -an. That'll show me all the ports, and also it won't bother trying to do name resolution. So netstat space -an will show us all the ports currently in use on this system. So if we take a look at the ports, the interesting part here for me is that we've got this port right here, 10002, 1047. That's the channel we just established. And it's going to this machine, 10004. That's the Backtrack system at port 4444. That's currently an established session. And on closer inspection, I have a whole bunch of additional ones up here that were from previous validations as I was preparing for this demonstration. Now, to get out of this shell, we're going to do a Control-C. It's going to say, do you want to abort this session number 1? I'm going to say yes. And I'm back to MSF console at the same position before I actually typed in the word exploit. To exit out of here, we can simply type in exit, and that will take us completely out of the MSF console. What I think would be fun for us to do is do that same exercise again, but this time use Armitage. Armitage is simply a front end for Metasploit framework. So on Backtrack, I've logged in as root. I've launched StartX for the graphical user interface. We're going to bring up a command line interface and simply type in Armitage. And that will launch it. It'll automatically prompt us for connecting and starting everything it needs to function. And this will give us the opportunity to work with the graphical user interface as a front end to Metasploit. Now on the Backtrack system, it doesn't always do this, but it's asking me about what is your current IP address. So I could bring up a command line interface and verify that. It currently is 10.0.0.4, so I'll supply that information. Click OK, and now it's ready for me to go ahead and launch the attacks. Just as before, we've got the MSF console interface down here, and then we have the GUI interface up here that we can go ahead and play with. So how do we get devices into the Armitage graphical user interface? First of all, we're going to go to host and say we can import them, such as an Nmap or something to that effect, or we can just launch an Nmap scam right here, and it'll do it. So let's go ahead and do a quick scan OS detect, and then specifying who do you want to attack or who do you want to scan. And we'll say 10.0.0.2, press enter, and it's off to the races using these really cool Nmap traditional options right here. And check it out, it's doing the DB underscore because it wants to add that to the database that Metasploit can then use over and over again. So it's finished. It took 17 seconds. It says based on this, it says, okay, congratulations, use attacks, find attacks to suggest applicable exploits for your targets. This is so cool. So what they did was, based on what they found with the scan, it can recommend various types of attacks which are applicable or might be applicable to that victim or potential victim. So we'll click on OK for that and check it out. There's our 10.0.0.2. So the Linux is going to show up with a little penguin, and other types of operating systems based on what they are might have a different logo. And we can also tweak and tune that as well. So if we do more advanced scans, we find more details about that platform, it can more correctly identify the operating system. But it nailed it. That really is an XP box sitting right there. So we can go ahead and move this around. If you have lots of devices, you may want to choose a view that has them in rows instead of as icons. But our attack earlier, we loaded the module of exploit Windows SMB and the one called MS0867net API. So we could do that this way as well. We could go ahead and open up exploit. And under exploit, we can go down to Windows. I'll scroll down to Windows. And under Windows, SMB, which is right here. And then in our SMB, we had several options, and we're going to choose the option of MS0867, which is right here, the Net API. So if we double click on that, we can go ahead and put in the values, and we're good to go. Another way of doing a very similar thing is this. Instead of launching it, which we certainly could do, we can go ahead and go under attacks and say find attacks. And what this will do is say, okay, based on the host in your database, and because I know it's Windows XP, let me go ahead and find a bunch of attacks which might be appropriate. So we'll click on find attacks, and in just a moment it's going to come back and say, great, I have loaded up a bunch of attacks that might be applicable for that device. Simply use the attack menu associated with that host. So it makes it very, very simple. So I'm going to click on OK. Now I can just right click here and check this out under attacks, SMB. Here's all the ones that it thinks might be likely to work on that platform. And sure enough, there's our MS0867 Net API. So to launch this, I can just click on it, specify the local host, which is already in because it knows who the backtrack system is. The R host, it knows it's 10002, so it already pre-filled that. And I can just go ahead and launch it by clicking on the launch button, just like that. The attack is going to open up in a separate window down here, and it's now succeeded. And we now have this thing called Meterpreter, which is a meta interpreter. You also may have noticed that this icon changed to red with lightning all around it to visually imply that this device has now been compromised with our exploit. So down here, very similar as before, we have the ports involved. So it's our local port 49,130 going to the victim at 13,846, any port in a storm, as long as we have that connection. And now this Meterpreter actually gives us some additional options and functionality, which are pretty cool. Now the question is, okay, Keith, how do we use them? With MSF Console, we simply were given the command prompt at the victim's machine. How do we use it here? Well, to leverage this, we go back to this machine, right-click, and see this Meterpreter right here? We have the options of access, so we can migrate, escalate privileges, steal tokens, dump hashes, persist, pass session, interact. Let's go to interact. So if we go to interact, say, I want a command shell. Click, and it's going to open up a new tab with our command shell once again. Another really amazing concept is hopping applications. For example, right now, we have compromised a service called Service Host on that Windows XP machine. That was our initial attack and what it leveraged. However, if we want to move that to another process and keep our connectivity, we could migrate from that application to a different one. To do that, we simply right-click on the host. Under Meterpreter, say Access, Migrate Now, click on that. It'll say, oh, you were on Service Host Process ID, blah, 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 blah. We'll migrate you to Notepad.exe Process XYZ. Now, I've already done that once on this system. I'm going to go ahead and migrate again to another application. So I clicked on Migrate Now, and now it's saying, okay, you were on Notepad, Process ID 540. Now I'm migrating you over to Process ID 1700. So if we were to look at Task Manager and take a look at all the processes running, we would definitely see Notepad.exe sitting there, which to the average user wouldn't seem like a big deal. Okay, Notepad's running somewhere in the background on the system. Unless, of course, it wasn't really running and it was a malicious person connected to that process. So we'll click on OK to dismiss that message, and we still have our connectivity. One of the benefits of Armitage is that it helps you sort through all the attacks that might be applicable to a device. So instead of having to search a list and loading the right module and the right payload and everything else, we can simply go to Attack, specify the detail we want, and then go ahead and launch it. We can also do a check, just to check before we actually launch the attack to verify that that exploit might be viable and workable on that system. Another really cool option is, let's say that we've compromised this system. We're going through a firewall or two, maybe it's a few hops away, and we're just wondering, hey, I wonder who else is on that network with that device. We could right-click and simply get a lot of information from this host. For example, we could go to Meterpreter again and go to an ARP scan and see what's in the ARP cache of this device. So we launch it and click on ARP scan. It'll bring up a new window for us. It's going to show us, okay, here's everything in the ARP cache of that host. He knows about 10004. You bet he does. That's us. We're the backtrack device. He also knows about this guy right here, 10001, which happens to be his default gateway. He also knows about 10002, which is his own address. And he also knows about 10055, which is another computer that is sitting on that same subnet. So a lot of information can be gathered about other devices, and it started to put up icons representing those. If you don't want those in the database, you can simply right-click on them and say host, I want to remove it, and host and remove it, and host and remove it, and it will remove those. If you want to remove all the devices from the database, from the workspace, you can simply go to hosts, clear database, and it'll simply remove all the devices from the database that Metasploit is currently working with. Again, Armitage is just a really great, in my opinion, front end for the tool called Metasploit and the framework that surrounds it. I've cleared out the database in Armitage because I want to share with you one additional feature that's pretty darn cool, and that's like a last-ditch effort. If you're not sure exactly which module or which exploit or which payload you're supposed to be using, this is a method that can be used mostly as a last-ditch effort to try to compromise a system. And to do that, let's go up to hosts, and we'll say we want to do an Nmap scan, and let's go and do a quick OS detection of 10.0.0.2. I've also rebooted that victim, so he's nice and fresh, and there shouldn't be too much still running on him from any previous attacks. Now that that's complete, we'll click OK. We'll get our icon for that device right here. You'll notice it's not red and lightning bolted yet. We'll fix him in a moment. And we're also going to go to attacks and say find attacks. So it's going to take this device, which it knows it's Windows XP based on the scan, and it's going to identify, hopefully, relevant attacks for that device. So we'll click OK. Thank you very much. Now we could right-click right here and say attack, but which one do we issue? I mean, we could try them one by one, I suppose. Another method of launching a whole bunch of attacks, which is not very stealthy, but it is a lot of fun, is use this option right here under attacks. Use the Hail Mary option. So we'll go ahead and launch that. And it finds the exploits via local magic, and it said it found 21 exploits, and now it's going to launch all 21 at this device, which it's amazing. All we need really is one that works, and then we can get remote access to that box and then do whatever we want from there: privilege escalation, keyboard logging, etc. So now it got it. It had some success in compromising that system. Let's right-click on this device. And it has two, not just one, but it had two different attacks that were both able to open up Meterpreter sessions with it. So all we really need is one. So let's go to Access. And before we do the migrate now, let's go ahead and bring up our victim just to take a look at what processes are currently running. So we'll bring in our victim. Here he is right here. And we'll right-click. We'll go to Task Manager. And in Task Manager, if we go to the actual processes that are running, we'll sort them alphabetically. There they are. And one of these service host guys is currently asked. So we're going to migrate it. If you'll notice, Notepad is not running on this device. So alphabetically, it would be somewhere in there. So we'll go back to the attack machine. We'll say, I want to go to Meterpreter. We'll go to Access, Migrate Now. And it will automatically says, poof, okay, I'm going to migrate you from service host process ID 1168, and now you are Notepad. So if we go back to this machine, all of a sudden, magically, there's Notepad that's running, which is now running with its open ports, allowing us to go ahead and maintain our connectivity with that device. Now, it gets even better than that. So I'm going to click OK on there. I'm going to right-click on this guy. And let's do this. As far as Meterpreter, let's go ahead and interact. So we can do a command shell. We've done that already. How about this? Let's go ahead and do Explore. We could browse the file system. Great. So that opens up a new window. And right here is all their files. Great. So we can navigate their file system and take a look at all their files. If we want to go back and go back to Meterpreter and go back to Explore, we can go ahead and say, I want to see your keystrokes. Great. So now we're going to do key logging. So we'll click on Launch on that. A new window opens up, and we'll go back to the attack machine. It doesn't really matter where we type in on the victim machine, whether it's a browser or a word processor, because that's all those keystrokes are going to be recorded by the actual MSF console. So let's give it a whirl. Let's go ahead and let's open up a browser. I think I've got internet access still, so we'll go to google.com. And we're trying to go to google.com. I need to verify my default gateway and DNS and everything else. But if you'll notice, regardless of our success in getting to that website right here, it recorded it. It said, okay, keystrokes typed in google.com. Let's try another application, one that we don't have to rely on internet connectivity for. Let's go to Notepad. There we go. So Notepad, this is a very secret password or a passphrase or something to that effect. So we type that in inside of Notepad and check it out. It got all of that right here. So, and even got my backspace. So this is a T, and then I had a backspace, very secret password. It captured all of it. And there's the actual file that it's going to store it. So I can go back to that file and get everything. So any passwords or anything else this person is typing in, I now have them. And that's a very serious compromise for any system for keystroke logging. One other one, which is a lot of fun too, is we'll go to Interpreter, we'll go to Explorer. Now I don't have a webcam on my virtual machine, but if you want to get a picture of the guy who's sitting at that computer, you can do that as well. We'll go ahead and do a screenshot. And we'll get a screenshot of whatever's currently on that machine, which is right here. And that opens up in a separate window as well. So you can see how the Hail Mary attack, we could do all those other options through one Interpreter session, by the way. But if we're not sure which exploit might work against a given device, using the Hail Mary option is a significant method for discovering what might work against a target. In this video, we've taken a look at working with MSF Console using the interface provided by that by taking a look at the workspaces, scanning for devices, loading up modules, specifying the payloads we want to use, setting up variables, and launching the attack. We also took a look at using the graphical front-end Armitage to do the exact same attack. And we also discovered that using Armitage and some of its automation tools can make the process of deciding what vulnerability would work against the system that much quicker. I've had a great time. I'm so glad you've joined me. As in all of these videos in this set, please make sure that you are authorized to use a tool before you attempt to go ahead and use it. I've had a lot of fun. I hope this has been informative for you, and I'd like to thank you for viewing. Using an attacked host as a pivot point. Let's say you and I, in an authorized manner, compromise a system, but we find out that that system has additional connectivity IP-wise to other networks behind it and other systems. We could use that compromised host as the source of further attacks to go deeper and deeper into the network. Let's begin. I'd like to chat with you just a moment about the concept of firewall design in general. The basic practice is this. A firewall is to keep two things separate from each other. So if we have a firewall, we'll label him firewall 1. And let's say we have him connected to the outside world. So let's say this represents the untrusted network, maybe the internet or some other network that is not in our control where we don't have manageability over those users. So let's say the internet as an example, and oftentimes they call that the outside. And then we have our trusted networks where we do manage the users and the computers, and that might be called the inside. And this would be an example of our most trusted network. Or when we talk about our most trusted network, that's kind of an oxymoron, because even though it's our network and we manage it, customers on our networks can still launch attacks. We still need to be careful. But this is our inside network, and let's say we have a lot of computers and devices and servers and such. And we also might have, for example, a DMZ, a demilitarized zone, with maybe a server or two on it. And the concept is this. If you have a user on the outside right here, we never allow them direct initialized access to the inside. We just say no. That's our policy, like Nancy Reagan from many years ago. Just say no. So that way the firewall says when this customer, let's call it customer 1, he tries to go to an inside resource based on network address translation rules and firewall policy, the firewall says no, can't do it. At the same time, customers on the inside, if they go out to a web server, for example, the firewall does stateful remembering, stateful filtering. It remembers that session, and it dynamically allows the return path to come back in. And that's the benefit of any current generation firewall at a bare minimum, is stateful remembering of what's going through to dynamically allow the return traffic back. So for users on the outside, like this guy, we might poke holes and open up paths so he can get to specific DMZ servers and so forth, but never directly to the inside. So that's the basic concept of firewall rules in general for computer networks. Now, what does that got to do with this pivot attack? Well, this pivot attack is pretty amazing. Let's say we have this computer right here is Backtrack, and he's locally connected. How did he get an IP address? Just like everybody else. Either he got it through DHCP or he guessed at one and put it in. And now let's say he scans the network. And let's say that we aren't patched, we're not current, and he finds a vulnerability. And let's say he doesn't find a vulnerability here, but let's say he finds one on this server. This server is what this is called multi-homed. It's connected to two different networks. Oh my goodness. And if that's the case, if this guy's connected to two different networks, that means he has access to both of those networks. So let's say there's no firewall between this. In fact, let's say there's no connectivity whatsoever between these two subnets, these two layer 2 broadcast domains and IP subnets. But the server is attached to both. If we compromise the server through some vulnerability, some unpatched system or some application that has a known vulnerability, and we take advantage of that, we can do what's called a pivot attack. So here's our backtrack. We compromise him, and then we ask him, hey, let's go ahead and find out who's out here. He then launches the scans on our behalf. So we own him, right? So he's doing all the scans out here to find out what the devices are, and then we can further propagate our attack into this network. We don't have to be connected, and we don't need direct IP access from this subnet over here as long as we have a compromised host who does. What a wonderful and dangerous thing. So here's what we're going to do. We're going to compromise this device right here who is multi-homed. And we can find that out very easily just by asking him. And then we can do an ARP scan where he's going to do an ARP request across this entire subnet, see who responds. We'll find out who the potential victims are. And then we can continue our scanning and compromising of those systems if they're vulnerable. That's the game plan. Let's begin. So we have connected to the physical network, and now we just need an IP address appropriate for that. So let me go ahead and bring up a command line. Let's use DHClient. That says, please give me an IP address from a DHCP server, and we'll specify the interface, which is Ethernet 0, and that should go out and get us an IP address. So even if we had a statically configured IP address before on a different network, the DHClient is going to give us the opportunity to dynamically get an address, and it looks like we're in good shape. So we have 10.0.0.10, that is our IP address. We could go ahead and confirm that real quick with an ifconfig. And sure enough, 10.0.0.10. And let's just make sure we can hit the default gateway, which is 10.0.0.1. Just want to make sure we have connectivity, and we do. Control-C to stop that. Just want to make sure we have connectivity before we start our attack. So let's go ahead and launch Armitage. And with Armitage, we'll go ahead and say yes to everything. Oh, what's the IP address you want to connect to? It's ourself. What's the port? You want to start the RPC service? Yes, yes, yes. So just for fun, I went to hosts and I said clear database. So I've removed any of our previous work. Also, if you had some previous scans and work that were going on, we could verify that by going to view and to jobs. It would list any current jobs that were running in the background here, and you could highlight it and kill it if you wanted to stop those jobs. So a lot of the processes that will run in the background, this is a great way to view them. It's also a great way to stop them if you're done with those. If you're done with that tab, which we are, we just click on the X to close it, and we're back to a fresh start. So we know we're on the 10 network based on the IP address that we were given. Let's go ahead and find some potential victims. So we'll go to host, and we can do an Nmap scan or an MSF scan. They'll both get the job done. Let's use an Nmap, and let's go do a quick scan with OS detection. It says, who do you want to scan? I want to do the 10.0.0 network /24 bits, and click OK, and it's off to the races. And that'll take a few minutes to complete. So here's the Nmap command it's doing, where the DB is to go ahead and include it inside the database that MSF is paying attention to. And then we have our fairly aggressive timing and discover the operating system. The -F says, hey, I only want to look at the top 100 ports as opposed to the top 1,000. So all those same Nmap commands that we looked at in previous nuggets, we're going to leverage those here once again. And it has found some results. I don't think it's quite done yet, but it's found several. And as it completes, which will take a moment for it to do, it should pop those hosts up into this topology up here. So this is the 10.0.0 network that we're scanning, /24. And I know there's at least a couple devices there in my little test network that should appear for us. Okay, great news. The scan is complete. It says, please use find attacks to suggest applicable exploits for your target. Sounds great. Let's do that. So, wow, look at that. Oh, it put them back to back. Okay. It stacked them all up on top of each other. I was like, why is it all munched up? All right, so there's what it found. It found a Cisco device at 10.0.0.1, and it found a couple different flavors of Windows, it appears, and some Linux boxes. Fantastic. Now, this one right here, this Windows box, is my host machine. I do not want to damaged that one. I'm going to remove that from the topology so it's not included in any attacks. I did this to myself the other day. I was working on one of these nuggets, and I did a scan, and I did a Hail Mary, and it totally took out my host machine. I was like, why did it stop recording? You just killed yourself. Ouch. So I'm going to say host and remove that host from the list. I don't want to attack him. And let's see, the 10.0.0.10 is our backtrack machine. We just discovered that from our ifconfig earlier. That's great. 10.0.0.50, Windows XP box. And this is another Windows XP at 10.0.0.6. And Cisco iOS 12.x. Fantastic. Okay, and what's this guy? And that's just a flavor of Linux Ubuntu. We'll find out more about him, I suppose, if we do more scanning. Okay, so what we're going to do is let's go ahead under attacks and say find attacks. And one of these devices, and at the moment I don't recall which, but one of them is connected to both networks. So we've got the 10 network, which I'm directly connected to, and one of these devices is multi-home. In fact, I'm sure the router is. It's very likely the router is connected to multiple networks, but I'm going to use an exploit on a server or PC that's connected to 2 as well. So let's go ahead and let's try this guy right here. We'll simply right-click on him, go to attack, and because we already know from our previous nugget that we have this SMB MS08067 Net API, that's a winner. We can just launch that and just go ahead and attack it. So let's go ahead and do that. And all the details are put in regarding the R host, which is who we're attacking, the local host, which is us, and you can say, I want to do automatic targeting, or you can get very specific if you know exactly which version or flavor of service pack that it has. So I'm going to say use automatic and click on launch. And that's going to launch that job. So right here, I'm going to pause the screen just for a minute. That -J is where it's launching the job in the background. And if there were any jobs that were running in the background that we wanted to see, we could go to View and Jobs, and it would go ahead and open up a new tab to show us that. But this one is complete. It opened up the channel. This guy is now compromised. So our next step for our pivot attack is let's see what else this guy is connected to. What other networks is he a part of? So we'll simply right-click, and we'll go to Meterpreter, and we'll say, you know what? Let's go ahead and do an ARP scan. Now, this ARP scan, it appears that he is not connected, because if he was also connected to that 172.16 network, it would have information for that as well. So let's say, oops, not that one. Let's go over to this guy. Maybe it's this guy right here who is connected. This is probably the discovery process. We'll go to attack, SMB, and launch it, and that'll take just a second as well. And now he's compromised. Again, I'm picking some easy targets. What I would strongly recommend for you to do is that as you practice with this in your test lab, take some operating systems, don't patch them, so you can start practicing with them. Now, in a production environment where you're authorized to do pen testing, you'd want to make sure you're up to date. What are the latest vulnerabilities? What are the latest attacks in Metasploit that would leverage that vulnerability, et cetera, et cetera. So here we're just working on the concept of using the tools. So if we right-click on this guy and go to Meterpreter and say ARP scan, there we go. Thank heaven. So this guy at 10.0.0.50 is overt channel between the attacked victim and our backtrack device. And if we are on a different IP address than what we appear from the other side of the NAT, we need to supply that. I am not. In this case, the client that we're going to be doing the attacks with and us, this backtrack system, we're both sitting on the 192.168.1 subnet. So I'm going to say no to that. Press enter, and now it's saying, okay, what is the address that you'd want to use for the reverse connection from the attacked victim back over to the backtrack system? And the address is 192.168.1.23, the same address we verified just a moment ago, and we'll press enter. Earlier, we said we wanted to use a template, and now it's asking us which template do you want to use. Do you want to have number 1 that looks like there's a Java application that needs Java, or number 2, Gmail, 3, Google, 4, Facebook, 5, Twitter? All we're doing is we're trying to fool the user for a few seconds while our malicious code hooks into the system. So I'm going to go ahead and I'm going to use number 1, Java required. It doesn't mean that Java is required, really. It's simply going to be that type of a message that the client sees, and we'll go ahead and press enter. And now it's asking about the type of browser exploit that we like to use. Oh, there's so many. I'm going to go for 33. 33 is the Metasploit browser auto own. It says use at your own risk. This isn't a test environment. I'm okay with that. I'm going to choose 33 and press enter. And now it's saying, okay, great. What do you want to do? And I want to use number 2, which is the reverse TCP Meterpreter. We've used that before. with the Armitage front end. It works like a champ. Let's use that same one and press enter. And now it says, okay, what port do you want to use for the reverse connection? I'm going to say 443. That's the default. And press enter. What's going to happen? It's going to take several minutes for it to crank out all of that malicious code. And basically, it's going to create a web server. Now, what I discovered is that on some systems, if you have the ports already in use, for example, let's say you have Apache already running on port 80 or something else already running on port 8080, you might need to identify what that is, turn off that service so that this tool can create the new website and host the content. So whether you have Apache or something else that has an open listening port. So one way of finding all the open ports is to go ahead and do this. It's netstat space dash ANTP. And what that will do, it'll show you if you have ports open on, like, for example, 80. And if you do have something already currently using that port, you'd want to go ahead and kill that process so that this software can go ahead and assume that role for the malicious website it's going to create. So regardless of which exploit takes advantage of that system, we're going to get the reverse TCP coming back to us. So it looks like it's almost done. It found 34 potential exploit modules that it'll be using. And now all we need to do, I'm going to press enter one time here. And what we need to do is we need to now trick the client into coming and visiting us at this address right here. Now, how in the world could we do that? Well, we could mess with DNS, perhaps, or we could send them an email that looks like it's something official, like click here for yada yada. They click. If they go there, all of these exploits are going to be tried as payload against that target system. And I'll tell you what, I know at least 2 or 3 of them are going to be successful. And we're going to have a reverse TCP session back to us. And the Meterpreter is available then to be used to do virtually anything we want with that remote device. So let's bring in our victim. So I'm going to just drag this over here. He's a happy guy, or he's not going to be, but he's happy now. And he's going to go out to the website. So I'm just going to manually put that address in. But you can see how it might be fairly easy to, via email or some other link or some other option, make that client click and go to the website. And if he does, he's owned. So let's go ahead and I'm going to copy paste this. I'm going to copy this right here and go back to my client, paste it in. Now, if this is successful, the code is going to execute. There's going to be some privilege escalation. It's going to hop some processes. And this Windows box right here is going to initiate a connection back to this backtrack system. And that will give us a Meterpreter console that we can then go ahead and use to do a whole host of things to this victim. So let's go ahead and cross our fingers and press enter. All right, so basically the client's sitting here. I don't see the Java message. I'm not sure why. Normally, maybe we didn't get that far before we blew up. Normally what happens is on this screen right here, you'd see this Java, this requires Java. It has like a list of 3 things to check, blah, blah, blah. The user's looking at it. Meanwhile, nothing really is needed to be done by the user. His machine's already compromised. So I just took off the pen. That web browser disappeared. It basically was corrupt. We had already jumped ship, by the way, to another process, so there's no problem there. So this migrate command here is what was migrating to additional processes on that box. So we're in. In fact, if we want to take a look at how good we're in, let's go ahead and press enter here, and let's type in sessions. And that will show show us our existing sessions. So we have 3, not just 1, but 3 different Meterpreter sessions open. 3 channels open between this backtrack system and this poor victim right here. So ports 1050, 1052, 1053. If we did netstat on that victim machine, we'd see all those ports are open and established over to us. So the next question is, okay, Keith, how do we actually use one of these sessions? Good question. We can type in sessions again and tab that out, and we do a -I. And then which session do you want to use? We have 3 choices. We can do session ID 1, 2, or 3. So let's go ahead and choose session ID number 1. Press enter, and now we've got this beautiful Meterpreter prompt. So Keith, what do we do with this? Well, the Armitage makes it really easy, huh? You right-click on the host. There's tons of stuff. But with Meterpreter, how would we get help? That's my question. How do we get help in the world of most of our Linux stuff? And the answer is we use the help command. or we use the command -H or -H or -help. So if we type in help right there, I'm going to go ahead and scroll up so we can see this. Here is all the help starting way up here for Meterpreter. So we could go ahead and we could kill processes. I'm going to scroll down a little bit. We could type interact. We could migrate, which it already did by default in the background for us as part of the set toolkit that helped us with that. So these are all core commands. If we scroll down, we have file system commands. Fantastic. We can change directories. We can download files. We can upload files. We can remove directories. We can make directories. That's great stuff. Let's go ahead and see what else we can do. We can do ifconfig. Now, on a Linux box, that would be great. On a Windows box, ipconfig would be more appropriate. And ipconfig will show us the details. We can do a route command to see what the routing table looks like on that individual host as well. If we scroll down to system commands, look at this. Clear EV, clear the event log. Oh, that might be something good to do before we reboot that machine. So the event log, at the moment, it should have a whole bunch of events in it. In fact, let's check that out. So to do that, we'll go back to our client and we'll go to Start and Control Panel, Performance and Maintenance, Administrative Tools. We'll get there eventually, and here's the event viewer. So if we open that up and look at the application logs, oh, there's a bunch of them. And if we look at the system logs, there's a bunch there. So if we wanted to just get rid of all those to kind of hide everything that happened on that box, we could use that command right here, clear EV, and that would do it for us. In fact, I'm going to copy paste that in, and we'll just launch it. And it's done. It just got rid of all those. No problem. Easy enough. So we go back here and we refresh this. There's nothing back. It wiped them. Fantastic. Great tools. All right. What else can we do besides erase the event log? We could, oh, I like this. We could execute commands. Let's try that real quick. Let's go ahead and execute. And the execute command, we're going to do execute-f. And let's go ahead and launch, how about calc? calc.exe. That's a local program in the Windows operating system. So we'll launch it, and let's go back to our client real quick. And where is calc? There it is. So it launched calc for us. Fantastic. I love it. So let's go back and see what else might be fun to do. Now the reboot and shutdown are pretty cool. When we're done, we could reboot or shut down the computer and hopefully erase most of the trace that we were ever there. So we also have this keylogger again. So we can actually take keyscan start, go ahead and copy paste it there, run it, and now it's starting to record all of our keystrokes. So if we go back to an app, in fact, we could, if we want to, we could actually start for them. We could start Notepad. You know, just don't want to have to make them do too much work. Popping up applications. So here's Notepad, and anything we type in here, like, hello, mom, how are you, question mark. Good deal. So all that should be recorded, and we can dump it if we want and see what it is by using the keyscan dump command. So we'll put that in, and there we go. Even got the back characters too. So hello, mom, how are you? Back, and then a question mark, and then a couple returns, which is exactly what I typed. So if I was typing in on a secure website or something else, and I was putting in my credentials, those credentials would have been collected. So once we're done to get out, we can go ahead and type in exit. It's going to say, okay, great. That was exiting that session interaction I was having with that session number 1. And if we wanted to exit again out, it's going to say, you know what? You've got a whole bunch of active sessions. If you want to get out, just type exit-y. And that will take you out. It's going to stop the whole server process. And courtesy of SET, it's all pretty much automated. Didn't take a lot of work except for choosing the options that we wanted to, specifying some IP addresses, and we're off to the races. In this video, we've taken a look at SET, the Social Engineer Toolkit, which is included as part of the Backtrack distribution. I would recommend you practice a little bit with it. Of course, in a test environment, you'd never do any of these tools on networks or devices where you're not specifically authorized to do so. I've had a lot of fun in introducing this tool to you. I hope this has been informative for you, and I'd like to thank you for viewing.